the same idea as like simplifying or reducing a fraction where we want to get our radical in the most reduced form that we can get it. So our first example is the square root of 192. So we need to remember our perfect square numbers, and we want to see if any of these go into 192. So 2 squared gives us 4, 3 squared is 9, 4 squared is 16, and we just keep going up and getting these numbers, and we want to know if any of these go into 192. You know, if you're not sure in looking at it, first just pick up a calculator, and it's an 81, and this list does go on. Pick up a calculator and just start dividing. You know, 192, see if 4 goes into it, does 9 go into it, does 16. With a big number like 192, you know, 4 might go into it, but keep going to see if there's a higher number, because what you'll see is that 192 can be broken down into the square root of 64 times the square root of 3, because 64 times 3 is 192. This is our product property of radicals, is that if you have, you know, square root of 192, you can break it apart into 2 separate radicals. And the reason why we picked the square root of 64 is because we know what the square root of 64, that's just an even 8. And then the square root of 3, if you notice all these numbers over here, none of those go into 3, so that is as reduced as that is going to be. So our final answer is 8 times the square root of 3. So then we move on to this next example. It looks a little bit more complicated. We'll see what we think of it here. I notice we have some numbers that are outside of the radical, you know, this 5 and this 3. I know that those are going to be multiplied together because those are considered like terms in a problem like this. So 5 times 3 is 15, and then we have square root of 24 times square root of 10. And, you know, we could do this a couple different ways to avoid working with really big numbers. What I did was I said, oh, square root of 24, I think I can reduce that. You know, that breaks down into, if I look at the numbers up here, I see that 4 goes into it, so that'll break down into square root of 4 times the square root of 6. And then we have square root of 4 is 2, square root of 6. None of those numbers go into it, our perfect square numbers. And we want to remember that our 15 does come down here. So we have 15 times 2 times the square root of 6. And now our 15 times 2 are both numbers outside of our radical, so we can go ahead and multiply those together. So we have 30 root 6. And then times, now I'm going to bring down this other square root of 10 we just haven't thought about yet. So we can use our product property of radicals in a backwards way where, you know, if we know that we have 2 radicals like this multiplying together, we can actually put those together. So we have 30 times the square root of 6 times 10, which is 30 times the square root of 60. And now we just, you know, we've been doing a lot of work. Are we done yet? Probably not. We need to look at that square root of 60 and ask ourselves if that can be reduced at all. Do any of these perfect square numbers in here go into it? I see the 4. 4 is a good one often because the square root of 60 can be broken down into 4 times 15. So the square root of 4 times the square root of 15. Don't forget we do have our 30 out front. So we have 30 times the square root of 4, we know is 2, times the square root of 15. So we're ready for our final answer. This is really sloppy with this pen I'm using. 30 times 2 are both outside the radical, and 30 times 2 is 60 times the square root of 15. And then just to make sure, the square root of 15, do any of those perfect square numbers go into it? 4, 9, well we can stop at 9 because 16 gets too big. And they don't, so I know that we have reduced that as far as we can. We could have done that in a different order, but in the end we would end up with the same answer.